And so thank you very much, everyone, for joining us today for this session. And I'm delighted to be with you for the coming hour. My name is Ralph Bodbol, and I'm heading the Knowledge Transfer Group in RAD. As you might know, RAD's business is networking, and for more than 4 decades, we have been focused on perfecting network elements, services, and life cycle to enable the CSPs and network operators to build and run multi-service, reliable, and cost-effective networks. But today, we would like to look at this business from a different angle. Let's talk about how your customers look at the service they get from you. Most of them surely don't care about delay variation and packet loss and other network KPIs. The concern is more about the user experience and service availability. To address this concern, RAD recently launched a new service, RADinsight. RADinsight is a service suite that is turning network data into customer-centric, meaningful, and actionable insights. To present this new service, I'm extremely pleased to guest RAD's marketing CTO, Sharon Rozov. Sharon, thank you very much for being with us today. How are you?
Very well, thank you. Glad to be here.
Great. And by the way, everyone will be able to ask Sharon questions using the chat and the QA icon in the toolbar during the presentation, so don't hesitate. And anyway, we will have at the end of the session some time for question and answers. So Sharon, stage is yours.
Thank you. So we'll start with a short intro of RAD. As Ralph mentioned, we've been a veteran in networking and a market leader in Ethernet access for over a decade. This is still a growing business for us as we were successful maintaining our innovation and agility in this domain. Our EAD, Ethernet access devices, some of you may refer to them as NIDs, needs network interface devices. They act as a demarcation point between the business customer's network and the service provider's network and provide SLA assured access into the service provider network. This is basically the underlay to run multiple business services, including VPN services, Layer 2 VPN, Layer 3 VPN, Internet access services, Cloud Connect services, and others. So RAD is offering, as I said, for a long time, an extensive product line, ASIC-based and FPGA-based of Ethernet access devices. Based on this product line, we are introducing a new services suite, RADinsight. So just to position RADinsight against our other products, I put this up together for you. So as we said, the EAD devices, the EAD product line is basically a layer 2 forwarding, these are layer 2 forwarding devices. Surely we have a domain management system, RADview, that is basically managing the layer 2 segment in the service provider network, the layer 2 segment and service in the service provider network, and also offering performance monitoring services for this segment. RADinsight is now a new service running on top of RAD's EAD devices. And this is, and RADinsight is spanned across the end-to-end service of business customers, spanning all the way from the customer's network, all the way to the application that resides in the cloud. So we're capable with RADinsight providing end-to-end visibility. And not only this, we provide customer-centric insights. It means that we let you know what the customer experiences and how the customer behaves. And all this is done based on continuous monitoring of traffic data and continuous analysis, AI-based analysis in the cloud. And this is offered as a service. So RADinsight, parallel to RADview and offering a larger span of view of business customer services. As I said, RADinsight is basically a services suite. Last month, we launched the first service. We call it RADinsight PM for performance monitoring. And we provide as a service an expansion, as I said, of the customer visibility as to the customer quality of experience across the services running on top of the layer 2 network. This is a survey that we conducted. Ralph, do you want to tell us about it?
Yeah. I was interesting to about this thing because last year RAD initiated a survey among the CSPs, and not only RAD customers, a vast panel of CSPs worldwide, and we have discovered that only 24% of the service calls received at the customer care center are related to the CSP1, to the CSP network. It means that 76% is not related to the one of the CSP. So how does it come, Sharon? How do we handle this interesting data?
So today, service providers accepting customer complaints about service cutoffs or service degradation, they can relate to problem areas within their network only, within their network segment only. They don't have visibility to the entire span of the customer service. So usually, service providers would get the complaints from customers and then initiate proactively monitoring, usually involving the technical teams to do so. Even when receiving the results of this monitoring, you need networking expertise to be able to read it and understand what it means. We think that it can be done differently. We want to be able to monitor the end-to-end services running on top of the service provider's network. We want to be able to provide instant views and continuous views of what's going on with the customer and with the customer services. And very importantly, we want to provide simple to understand, readable information, data by anybody working for the service provider or by the business customers themselves. So this is really, what we wanted. We, wanted to avoid, service providers having to deal with, finger pointing, the problem, the cause of the problems between them and the businesses, and therefore we created this service. So how it's done? So basically, as I said, the Ethernet access device is located at the demarcation point of the business customer. And we use passive measurements. We use mirrorings of traffic samples. Just up to 2% of the traffic is collected from the Ethernet access devices. And then we forward this mirror traffic to regional collectors that are deployed within the service provider network. To the same collectors, we also collect T1 KPIs. So we also run active measurements. You need to note that no probes No new probes need to be introduced in line with this solution. We utilize the existing EADs, deployed at business premises as um, as if there are probes, located in this very special location between the business customers network and service providers network. The PM controllers or reflectors, the T1 controllers or reflectors, do not need to sit in line. They're located typically at the peering point to the internet. No probes, as I said, are introduced in line. So in the RADinsight collectors, these are regional, collectors located in your network. We basically, with this service, we strip out the payload and we just move the metadata, basically the headers of the mirrored packets and the T1 KPIs to a public cloud where we apply the analysis of this data that we collect. And so basically, this is done, by avoiding any overload to the network, because all this mirroring is done in hardware, and no overload to the EADs and no overload to the network, because we're maintaining just a small, portion of the traffic is being mirrored.
Sharon, we have a question from the people. Malik is asking to understand if the session is, or the solution is offering a session awareness or just providing visibility into the application flows.
Yeah, I'll get to it later. I saw this question. Thank you.
Okay.
For this question.
But I still have a question, because I see here that we are collecting some data. Is there any traffic monitoring overload of the ETX device because of the RADinsight?
Yeah. So we do not hinder performance because we apply this in hardware. So this is done in hardware, so no hindering of the EAD performance. So so I said we are forwarding the traffic and data we collected to the cloud, and then we apply analysis. Let's look at this analysis. So basically, first we have all these packets, or more correctly, just the headers of the packets, and then we deduce the traffic flows from them. We basically group the packets into traffic flows, and we add on, we build the context. So now we don't have just, headers. We know which sessions we're dealing with, and who is the customer side, the service, the time. We build all this context. Then we assess the information, and we basically analyze the KPIs, the performance KPIs for this traffic. The jitter, the delay, the jitter, the packet loss. And then we also use this information, we correlate it also with the customer's history, and we give a per customer quality score that represents the quality of experience of this customer at any point in time. This is really a baseline, for the customer. And now going forward, we can compare the new quality scores we get with the history quality score, and then identify anomalies or exceptions in the customer's quality of experience. So we moved really from having network packets into building quality of experience score, per customer quality of experience score, and we are capable of identifying anomalies in a customer's experience. This can be also correlated with other sources of information, and either from the service provider network or from third-party sources, so we can enhance the the data to provide more insights. And then we are presenting everything we learned about the quality of experience of the customer. And this is really presented in a meaningful manner, easy to read. You know, we're talking in 10 base, you know, language, talking about services and customers and customer side. So it's really easy to understand and read by anyone.
Sharon, I'm sorry to interrupt. I have a question because when we spoke with our customers about those things, and the question that was popping up was the data privacy. It seems that the RADinsight can monitor the activity on layer 7. Isn't it a kind of a privacy break?
Okay, so in terms of data privacy regulation, there's no issue here. RADinsight doesn't maintain any data whatsoever about private people. So there's no implication to data privacy regulation, GDPR. And you know, more than this, for now, we only, we strip out the payload. We don't use the payload. We don't analyze the payload. We don't store the payload. We don't move the payload outside of the service provider's network. So there are no privacy issues whatsoever.
Okay, great. Maybe we can have a small poll to get some kind of feedback from our listeners. Can we do it? Can we do it now? Maybe. John, yeah.
Yeah, sure.
Okay. So let's have it. So the question is, what is the most common troubleshooting step you take for service complaints from the business customers? And you have here 4 possible answers. So people, if you do have some experience with the business customers' complaints, we would be happy to see if you can answer those questions. Maybe, yeah, some of you started answering, so it's interesting. We will have some more time for you to answer. We will finish in about 20 seconds. Okay, so it could be interesting to see what kind of troubleshooting steps are regularly taken when customers complain. Okay, so we have, yeah, quite a lot of you are answering. We'll give a few seconds more. Okay. Already 57% of participants participated. Yeah, we have 5 more seconds. 3, 2, 1. Let's end this poll right now. And I will share also the results with you guys. Okay, so do you see the results?
Very interesting distribution between the different answers.
Yeah. Okay.
So it looks like different service providers use different methods today to address complaints coming in, but still all of these options are very technical. You need to involve, I guess, technical people to do this. We think that one can minimize the length of calls with with business customers complaining on network issues. You can minimize them or avoid them altogether. And if you have instant views of what's happening in the network that are readable by anyone, and all this cumbersome and expensive support processes can be avoided altogether.
Okay, so I will stop the sharing. We can maybe continue.
Thank you for answering this. Okay, so I remind you, we collected the data, we analyzed the data, we have insights, and now I want to share with you what type of insights, how the insights look like.
Mm-hmm.
So we're able of segmenting out the problem area per customer site between the LAN, the WAN, and the cloud. For the LAN, we're capable of providing quality scores and KPIs per source IP. So in a large business customer site, where the LAN may be segmented into different segments, and each one is represented to the outside world as an with a separate dependent IP address. We would be able to tell the customer, not only we see that the problem, is not in our network as service providers today know, we would be able to tell the customer, the problem is in your network. And not only we know it's in your network, we know it's in this specific network segment of yours. So this is much more credible, and provides the business customer more visibility than just saying, no, it's not ours, it's not in our network, it's somewhere else. This is bringing real value to the customer. And this is really, what I refer to when I say avoiding the finger pointing between the customer and the service provider, shortening the time of support calls, and avoiding all sorts of support processes. For the one segment, we're capable also of presenting per customer KPIs and quality score. And for the cloud segment, per customer site, we're capable of presenting per destination IP, the KPIs and the quality scores, quality of experience scores for this customer site. We'll show it very soon in a demo, maybe now. So I guess we.
Yeah, would you like to move to the?
I just want to mention that the demo that we're going to present was built as a service provider dashboard that is a service provider that is accepting the business customer calls, complaining on network issues. And this is going to showcase what type of, visibility we provide with RADinsight PM. And the same dashboard can be used also by business customers as a self-service portal. And so business customers would be able to themselves to see what's going on in the network and avoid, talking to the service provider altogether. And let's move to.
We have a question, Sharon,
please.
To know if we detect Wi-Fi performance.
No, the answer is we do not. We do not detect. We see the LAN, regardless of the LAN technology used. So, of course, Wi-Fi could be used by the LAN, but not specifically Wi-Fi performance. Okay.
Yeah.
So this is the RADinsight dashboard. I just want to mention that this is running off the public cloud. It's running on top of a few Ethernet access devices that are deployed in our lab in Tel Aviv. And so the traffic that is running through them is real traffic. We inserted some network impairments in the LAN segment. So we'll see some, simulated network issues, but anything you see on the cloud domain is real and based on real life experiences. So let's say I accept a call from a customer. So I use this left side dashboard to choose the customer name, and then I can choose the customer specific customer branch that is now complaining, and I can choose a time frame, the last day or the last week, or even if someone complained, I had a problem last Thursday, so I can choose a date. But for now, let's assume someone just complained, something happened, in the morning hours or something like this. So what I have here, when I inserted all this, first I want to look at the top header here. And this shows me the three segments that I was referring to. What I see here are the quality of experience per this customer branch side. And it's divided into three segments. Of course, the color coding is straightforward. Green is okay, red is not okay. There's also yellow. And I can see, right away that actually the one network is okay, and and this customer branch is experiencing problems due to local area network issues and also cloud issues. And so what I see here, these graphs basically show me the calculated quality score. I remind you, the quality score was calculated based on the collected KPIs per this customer branch, only based on 2% of the traffic. And this, from these KPIs, based on the history of the customer, we gave the quality of the customer, we gave them quality scores. So this is the quality score, and I can then, try and focus on a smaller time range where I think the problem occurred. And so this is really to be used by someone that just looks at the quality scores. There's nothing technical here. And I can right away give the customer feedback and avoid, involving technicians. If I do want to, get into more detail, I can do so. For example, on the LAN segment, I see per source IP information. So each line represents a source IP. So let's assume I have 3 LAN segments. Each one is represented by a different source IP. And then I have the score calculated based on the round trip time, the jitter, the packet loss. And then I can look at a specific source IP within the customer's LAN and look at all these KPIs and quality scores and try to focus on what was the cause of the problem. Also, I can choose another source IP if I like and compare between the two. So this is for the LAN. The one.
Sharon, there's a question from Malik. What is exactly the quality score is defined here?
Yeah, so the quality score, basically, we collect packets. We from the packets, we analyze the KPIs, the round trip time, the jitter, and the packet loss. And then based on these KPIs, we give a quality score. But the quality score is relative to the specific customer's history. So for example, if I have a 20 millisecond delay to access a specific service at salesforce.com, and for me, it may be worse than I'm used to. So I would get a high quality score, meaning there's a problem. But for you, Malik, 20 milliseconds may be the usual, maybe even better than the usual, accessing the same service. So not only the quality score basically calculates the KPIs and the customer history, and then it represents the objective experience of a specific customer. I move to the one here. We have one service, just a single EVC. Again, we have all the KPIs and the quality score. And then I move to the cloud segment. I remind you that the cloud segment represents the services domain. So this is really showing us an entry per destination IP. So we collected all the different packets, and for a specific customer branch side, we grouped all the traffic going to a specific destination. And for this traffic, we assessed the KPIs and generated a quality score. And again, we can zoom in and go through the KPIs a long time and the quality score a long time for a specific destination IP, and then another destination IP, and we can compare them and try to assess what was causing the problem experienced by the customer. And as you see here, we used the destination IPs to, and we retrieved the destination name as appears on the internet. Some of them, for example, this Microsoft Corporation is an Office 365 service. Others, internet website destinations are basically terminating in a CDN. So we see here Akamai or sometimes other CDN names. And so if a customer knows that the problem occurred while accessing a specific application, we can also enter here a URL name and filter by it. So I'm going to punch in a popular URL, in Israel, because our lab is in Tel Aviv, so the traffic is here in Tel Aviv. So I'm assuming this is going to be generating some data. So now I'm filtering not only based on the customer side and the time frame, but also based on the URL. So now I'm presenting only the sessions that were headed towards this specific URL. You still see that they went through different paths through different CDNs. So we have a few of them here. One went through Akamai, another one went through Cloudflare, but we're capable of monitoring just these sessions headed towards the service that we're interested in. Any other questions about?
Yeah, we have some questions. Malik was asking to see some session level statistics, but I think that we have just covered it now. We have another question saying seeing 20% packet loss is nice. However, what is the root cause for this specific case?
Sorry, can you repeat it? So
okay.
Sorry.
Seeing 20% packet loss is nice. Mm-hmm. However, what is the root cause?
The root cause. Sorry. So first of all, we know the packet loss was in a specific network segment. So if the packet loss was in the cloud segment, we know for sure it was not in the service provider's domain. So the customer, the business customer that is used to call up the service provider for any networking issue, it has, can get now significant information from the service provider telling him, listen, not only the problem is not in my network, it's also not in your network. In this case, there was a packet loss associated with the cloud service. Okay, and you know, this is something that would be potentially helpful for the business customer that can now detect a problem with the cloud service it consumes, you know, or with the internet service. So this is really the idea behind it. If the packet loss was on the LAN segment, then the business customer would be able to look at a specific LAN segment and try to assess why it generated the packet loss. So we can tell exactly what happened in the LAN segment because we do not, you know, we do not manage it. It's outside of the management, you know, span of the service provider, but we at least tell the customer, we give the customer valuable information that, you know, where to look for the problem.
Okay, we have other questions. Malik is asking for RTT. Do you generate synthetic packets?
No. So what we do, basically, we're capable of using the traffic we mirrored, the packets we mirrored from the Ethernet access device, and we're capable of looking at both ways on the traffic traversing through the Ethernet access devices both ways and assess the round trip time for each direction. So from the EAD to the host and back to the EAD, and from the EAD to the application and back to the EAD. So this is really what we do, and this is utilizing, you know, passive measurements. This is the real traffic that is traversing the EAD. We only use synthetic T1 packets to be able to segment further between the service provider's network and the cloud, internet and the cloud network. Okay, so this is these are synthetic T1 packets that are going, as I said, between the Ethernet access device and a T1 a controller or reflector that sits in the service provider's network.
Okay.
I hope I addressed this question.
We have another question from Ben, trying to understand in the search if we support IP or URL only.
What other options you had in mind, Ben? So we have here, this is a URL search. Yes, we have, of course, the customer search, the branch search, the time frame.
Do we support IP search or just URL?
No, the IPs are all presented. They're all presented here. And now they're being sorted out from the worst quality score to the best quality score. So we're capable of basically, see the problems first in this list. But yeah, so all the IPs are here to be able to search within them. That's maybe a nice feature that we can add.
Malik is asking to know if we do have the round trip delay, or do we have also a one-way delay?
No, this is a round trip delay.
Okay, good. Lots of questions. It's very interesting. So can we just move on?
We can. So why? First of all, savings. We think that this tool can save a lot of time-consuming root cause analysis practices, and minimize them and save on on call center expenditures, support expenditures. It also simplifies support and operations. Avoid service cutoffs, and we think less technicians could be sent out. service providers may avoid truck rolls with this. So you see, it's very intuitive and instant, and that's what we wanted to achieve. And we also think this can increase the credibility of the service provider, avoid the friction points, finger pointing with the business customers, and basically deliver uninterrupted service to business customers. That's the ultimate goal. Okay, so we explained how we collect network data and return them into customer insights. And these customer insights basically tell the service provider more about how customers are using the network and how they're experiencing the network. From the data we collected, we currently showed you how we generated insights in the area of performance monitoring. But further down the road, we intend to enhance the insights and be able to generate insights around bandwidth utilization, services utilization, as in application utilization, security issues. And with this, not only we streamline operations and support, but we believe we can offer targeted upsell hints to the service provider and create new customer services for the service provider. This is surely, allows the service provider to grow productivity, credibility, and eventually revenue. So there's more to come with RADinsight. This is just the beginning of the journey.
Yeah, great.
I want to sum up with this. RADinsight is an add-on to RAD's Ethernet access devices. It offers 24/7 continuous monitoring across the network, across business applications. And it basically allows us, when we move the traffic samples to the cloud, it allows us to provide more functionality, more intelligence off the cloud without having to, update the hardware or the software on the Ethernet access devices. We avoid this altogether. Everything is happening in the cloud. All the new functionality is coming from the cloud. We provide intent-based analysis, and it's customer and service centric, meaningful and actionable insights that you can leverage, as we said, to streamline your support and operational processes. The dashboard can be used by service provider teams or by business customers, and this is entirely a subscription-based service per EAD device, so you can turn it on and off on demand. And I'm just trying to see if there Malik was asking about intent-based. Malik, I would love to take it offline with you. But there's a lot to read about intent-based analysis online, so please do. This is exactly what we do.
There was a question also, what is the difference between the PM portal and the RADinsight?
Oh, I see. This is a question for insiders. Again, I would love to, to take it offline. This is a webinar for anyone, for the public. So,
okay.
Any other questions?
Yeah, I think
still welcome to ask questions before we.
Anyway, even if you don't have questions now, two things. We have recorded this session, so we're going to send to all of you a link with the recordings of this session. It will come in the coming day, and obviously you will be able to send us your questions and maybe ask for some additional meetings to drill down much more with Sharon or with other people in RAD. So this is what is possible to do now. I think that if we don't have questions, we're going to just thanks very much everyone for being with us today. We had lots of interesting questions. We see that this is really a new service bringing a great added value. So thanks everyone. Thank you very much, Sharon. It was a pleasure being with you. And we just thank you. And we will probably meet very soon with some other web meetings and for some other products. So thanks everyone. It was a pleasure. That was Rad from Israel. Thank you very much and see you very soon. Bye-bye.
Bye. Thank you.